So our next topic is your normal distribution. So this is the another type of distribution. This is the like different from the binomial and Poisson. So in the normal distribution, you have to first understand this bell-shaped curve. So this is a bell-shaped curve which is like a symmetrical about the axis. So if I'll see this particular curve, this is like if I place a mirror over here, so this is exactly the mirror image. So that is why it is called as a symmetrical in nature. So first we have to understand the nature of this curve before understanding the normal distribution. So whatever the area under this curve, so if we have to study like this area under this curve, so that is none other than your probability. So whatever the area under this curve is called as the probability. And now the question under normal distribution can be like, let's suppose we have given with distribution of the marks. Let's suppose we'll take the example of the marks of the class. So we have a total of 60 students in the class, and I have taken the test of the statistics, maybe of the total of 50 marks. So I have taken a test, the total marks is of 50 marks and the student has scored the various marks into it, and the average, the mean of those marks comes out to be, let's suppose, 30 with the standard deviation of 5 marks. So let's suppose this is the condition that the average marks of the 60 students in this statistics is 30 and the standard deviation is 5. So now we want to calculate that how many of the students are having a marks which are greater than. So the question is the number of students who have scored greater than 45 marks. So this is the question before us, that I want to calculate the number of students who have scored greater than 45 marks. So first we have to make this bell-shaped curve to this. So the bell-shaped curve, the characteristic of this curve is the central line, that is always the average. So average here is our mean. So x bar value is 30 because the mean average is given to be our 30. So the central line is always the mean, and it is like symmetrical curve about the axis. So this is your 30. And now we want to find the number of students who have greater than 45. So 45 lies on the right hand side of this, because if this is 30, 45 lies somewhere here. So this is your x is equal to 45. Clear? And now we want to find the probability of the students who have scored greater than 45 marks. So we want to find the area of this thing, because anything which is greater than 45 is this one. So we want the find, and probability is area only, so we have to find this area which is the probability of greater than 45. Now how to find this? So for that we have to find the z value. So the formula for z value here is x minus mu divided by sigma. So this is the formula for the z. So here our x value is 45 at which we want to calculate. So z value at 45 is z45 minus mu is your mean and divided by 5 is your sigma. So this comes out to be 45 minus 30, 15 divided by 5, so that is your 3. So z value is 3. So here the z value is 3 and here the z value is 0. Because if we put 30 over here, so 30 minus 30 is 0 divided by 5, it is again 0. So always at the central of the line the z value is 0, and at the line of 45 we have calculated the z value of 3. Now what to do is we have to check the z table. So there is a table, so you are provided with the z tables, so which is your area under the normal distribution curve. So heading of that particular table, as you see the log tables, so the similar way you have the areas of normal distribution, so area under the normal distribution curve. So that tables are given to you, you have to ask with those tables. Without table you cannot do these questions. So in that table there will be like this, the table is like z 0.0, 0.1, 0.2, 0.3, 0.4 and so on, and here it is again 0.0, 0.01, 0.02 and so on. So now we have to check for the value of 3. So that is 3 here, and for 3.0. So 3.0 stands for, so 30. If you want to see for 3.06, so from 3 and whatever the 6 in front of 3 and 6, so that will be the value of your z. But here we want to find for only 3, so that is whatever in the 3 and in the front of this 0. So we'll get the value. So let's suppose 0.3052. So I am taking any random example. So let's suppose the value which is before this 3 and 0.0 is 0.3052. So what is this 0.3052 means now? So 0.3052 says that it is the area from the central line to that z is equal to 3. So this area is 0.3052. So this area is 0.3052, and now we want to find the area which is this one. Now the probability definition says, as we have already discussed, the sum of all the probabilities, that this complete area is 1, because it is the area under, and the complete probability sum of all the cases is equal to 1. So this all area is 1, which is symmetrical, and this is like, so this is also 0.5 and this area is also 0.5 because it is in exactly at the half. So this is also 0.5 and this is also 0.5, and now we know that this area is 0.3052 and we want to find this area. So this area becomes 0.5 minus 0.3052. So for that reason we are coming with the answer of like 0.5 minus 0.3052. This is the probability that the student has scored greater than 45 marks. And now I want to calculate the number of students. So the total number of students are 60. So we'll multiply this value with 60 to get the number of students who have scored greater than 45 marks. Now in the same way, now the B part of the question, let's suppose, says I want to find the number of students who have scored less than 20 marks. So less than 20 marks. So again I have to make this curve. So this line is your 30, 20 lies now on the left. So this is your 20 now. So this is your 20. So again we have to calculate the value of z at 20. So 20 is equal to 20 minus 30 divided by 5, which is minus 2 now. But again this value is minus 2 because it is on the left hand side. So z value comes out to be minus 2 in this case. But again we have to check the positive value because it is symmetrical. So whatever is z is equal to 2 is the same as at z equal to minus 2. So we'll again check the value of z at 2. So whatever the value of z at 2 comes, that is this area. Now we want to calculate the area which is less than 2 or less than 20, you can say. So this area you want to find, so that is again 0.5 minus x. So that will be your probability of the less than 20. Now in the same way, now you have to play with the thing. So anything can come. So let's suppose the question comes, how many students are there between 20 to 45. So between 20 to 45 is, you have calculated 20 to 30, you have calculated 30 to 45 also. So this area you have also calculated, this area you have also calculated. So x plus y is the answer of the probability of the students who have scored between 20 to 45. So any case can be there now, but you have to see this particular graph to find out if that required comes on the left hand side of the central line or on the right hand side of the central line. So depending upon that, you have to make your graph and you have to subtract or add the areas, and whatever the area comes, that will be your the probability. So that will be your the normal distribution. So in that case, these are the three types of the probability distributions. So do that, practice these questions, and then come up with the doubts if you have any on these binomial, Poisson and the normal distribution. Thank you.